Yes.
So as soon as you see a P, then you go back to C.
Yes. P-hat uses Z-score. And I'm going to give you the equations for this. I give you the formulas, so you should see that when you do the T, you'll see this. When you see the P, you'll see this. So as soon as you use a P-hat, there's your Z. See it? As soon as you use a standard deviation from the sample, there's your T. They're two entirely different things. P-hat is the proportion you don't have a standard deviation. So I thought these two were good to group together. Then the chi-square we do by itself because it runs a little bit different.
How many questions are in that?
I think 6. 6 with like different parts to it. Maybe, I don't even know. Not even that many. The vocab still, you have one more section to go. But if you have your vocab, I'll take it. Alright, this part, guys, was finding your cutoff value, your critical value. This was your table 5. Your table 5 or your inverse norm. Table 5 is nice for this because if you look in table 5, look up your degrees of freedom. Find two-tailed across the top, 0.05 degrees of freedom, find your cutoff values. Remember, your table is always positives. So if it's on the left, it's a negative. If it's on the right, it's a positive. I'll give you table 4, I'll give you table 5. If you do inverse T, just remember, you have to do 0.05 divided by 2. Okay, inverse T is different than inverse norm. Left tail test, again, use your table 5, degrees of freedom 14. One-tailed across the top, across the middle one, find the 0.005, give me the cutoff. On the left-hand side, it's a negative. Remember to label the shaded area, reject HO. The unshaded area, fail to reject HO. Good so far? Is it coming back
how
to
do we
you?
find the T-square?
You go to your table 5.
1.64 for some reason.
Because that's a Z-score. T-score, turn to table 5 in your back of your book. It's like 818. Yes. Say you're going to use a sample standard deviation. The difference between your population and your sample is that's where your Z to T goes. Your population is a Z-score, your sample is a T-score. So, table 5 will get you those values. Alright, this guy here, it gave us a claim, and the sample information, here's your sample. This is from your sample. This is from your population. Remember, your claim is made on your population. You test it with your sample information. You got a question?
You can plug it in the calculator.
Yes, you can plug it in the calculator. Question, Dan? Okay, how do I know this is a right tail test? Your HA. Your HA, the tail points to the right. HA is the way you make the tail. So it's going to the right, reject H0, find your cutoff, go to your table, N is 21, so your degrees of freedom is 20. One tail, 0.005, get your cutoff value. Okay, this is your test statistic here. This is your critical value. This is your critical value, or your cutoff value. This is your test statistic. This comes from your sample information. So you take your sample information, find your T-score. From there, you're going to see where does this fit. Slightly to the right of that. It falls in your reject HO area. So as a result, you're rejecting your HO. You're going to support your claim. Use the chart There is enough evidence at the level of significance of 0.005 to support the claim. We didn't know what the claim was in words, but we can write the claim down the way they wrote it. This is your decision right here. If I ask for a decision, it's going to either be reject H0 or fail to reject H0. This is your interpretation. This is your test statistic. This is your critical value. This is how you label your reject zones. Remember, there's no way to find your p-val off of this. You can only find your p-val with your calculator. Your calculator says stat, test, t-test. You can enter all this information in your t-test. Your population mean is 12,700. Your sample mean is 12,855. Your sample standard deviation, N, use your N, not your degrees of freedom. And your tail is your right tail test. Go down here, calculate. There's your t-score, there's your p-val. You won't get a p-val off your table because your table only gives you a z-score. It doesn't contain your areas. Remember, your t are a series of curves. So even though the area under the curve is equal to 1, that area keeps moving because your family of curves, as n gets larger, approximates a more normal curve and comes down to the axis. It kind of stayed up here first. As you get closer, it'll get closer to the bottom. So even though your area is still 1, the area is changing because of your degrees of freedom. So the only way to get that is with your calculator. If you use your calculator instead of your t-test over here, I need to see what you put in. I need to see calc, test, t-test, and tell me what you put in there. If not, it works both ways. I have no work to show, so you don't get credit. And if you do the wrong one, and you get the wrong answer from your calculator, you don't lose all your credit if I could see what you did. Some of you show me your standard deviation and it goes in wrong, I'll know it. Okay, here's another one. A fitness magazine advertises that the average monthly cost of joining a health club is $25. There's your claim, that's your HL. Your HA is complement. It's not equal to $25. So you've got the two-tailed test, your critical value at a 0.10 level of significance, and your sample information. Pull out all your sample information, 18, your sample mean, your sample standard deviation. Go to your table 5, find your critical values. Yes. Reject H0, fail to reject H0. This is your test statistic. It's in your fail to reject H0 zone. So if you fail to reject this, that means you have to go along with this. That means there's not enough evidence to reject it. You have to follow your chart. You can't say it's good, it's bad, I don't like it, I like it. You have to follow your chart. So you're gonna, not enough evidence to reject the claim that the mean monthly cost of joining the club is $25. Do you have a question you'd rather ask here?
What do I know? I was confused about something.
Well, this is more. Yes. Right now? Okay. All right. Okay, bye. You have to go see Miss Valentino. Okay. Here starts your p-hat. It was nice knowing you. Okay, here starts your p-hat. How do I know this is p-hat? How how do I know I'm out of the t-score and then
There's a
back
P
in?
right there.
There's your p right there. So that's how you tell. So I'm a proportion, a percent. Okay? Now, don't forget the test. This is the test to see if it approximates a normal curve. This test says, does it approximate a normal curve? All you have to do is check your smaller proportion. If your smaller proportion works, your larger proportion has to work. So just check your smaller proportion.
That goes in inverse norm once it's a p-value, right?
A p-value goes in inverse norm. But because it's 2 tails, you have to divide it by 2. Okay. Again, this is your critical value. Like Dan said, inverse norm. Don't forget, in inverse norm, to divide by 2. You got 2 tails. If you do 1 tail and you put in 0.05, remember it's going to give you a negative because it's the area to the left. If you're on the right, you make it positive. If you're 2 tails, you make the right positive, you make the left negative. This is your test statistic. I'll give you that formula. As soon as you see p hat, you know you're back to a z-score. Okay, same decision. Use your reject region. We can find your p-value for this because we just have to look up this z-score and find your p-value. If we look that up in your table, we get this p-value. We can compare it to your 0.05.
That can all go in the calculator too, right?
You can put this in your z-test, your one proportion z-test.
You multiply 0.09 times 40, right, to get your x?
0.09 times 40 to get your x.
I'm doing that, it's just saying error.
Because what are you getting? 3.6?
Yeah.
You can't put in 3.6.
4, right?
Yes, you can't put in 3.6. Remember, this is a binomial distribution, so they have to be in whole numbers. They have to be discrete. Now, I need to see where you round this to. 4 gives you a different answer than 3 does. Especially your sample size is not that large. So, right, because you went through 4. When you do it this way, we're more exact because we kind of used your p hat rather than your x value. So if you look when you do this, you can see your p hat slightly different because you had to round. It would be 0.1 actually if you used a 4. So it's slightly different. So make sure I see which one you use. So at this point, we have to say there's not enough evidence at the level of significance to reject the claim that my proportion is equal to 15. P hat, I don't know if you can see the little hat up here. P hat is from a sample. P is from your population. Okay, so make sure you get those right. Again, your HA is where your tail is. You have a left tail test. Check again, n times p, n times q, greater than or equal to 5. Just do a quick check. Set up your claim is your HA. In this case, set up your HO. Test statistic, cutoff value, and see where this falls. Yeah, you can be a fairly large or small z-score.
So find Q, P hat or the P?
P.
It's P, okay.
P. Yeah, this is about your P and your Q underneath here. The only P hat is this guy. This is P, Q. So whenever you find P, just find Q. If you found your Q hat with your P, it wouldn't match up. Questions? We're good? And this last one, a polling agency reports that over 60%, so it's greater than 0.6. Greater than 0.6 of adults feel that the federal government's bank bailouts were bad for the U.S. They sampled 298 U.S. adults. 167 is the X value. Out of those 298, a little bit more than half of them said that the federal government's bank bailouts were bad for the U.S. So it's a little bit more than half, right? So when you find your p-hat, it's X over N, and that number has to come out a little bit more than half. Is there enough evidence to support the claim? Support means that your claim was your HA, was your HA.
Calculator, do we need to find the p-hat?
Do you need to? No, not if you use your calculator.
Punch it in, right?
Yeah, not if you use your calculator. If you use your formula, you need to find the p-hat. The formula uses the p-hat, the calculator uses the x and the n.
And how do you find the x and n? That'll give some
You take your
p-hat.
p-hat times n, your percentage of your sample. Okay? Use your p-val test also. If you're looking up your p-val, look this up in your table. That's your p-val. Area to the left. Now, sometimes, look how odd this was. Your cutoff was here on the right. Your value was over here on the left. This happens. It could, number one, be an obscured sample, like not a really good representation of the population, or their percentage themselves could be really off. So that's what you're testing. Now, if you're the statistician, you may decide, well, I'm really pretty off on this. Let me do another sample. Let me test again, just to see if my sample is not there, not worth it, or is their values a little bit off. If I find that I sample again and I get the same thing, then don't take those samples out. They were valid. Their claim is just pretty off. Okay? Question on this? No? Alright, let's give you one to do. Alright. So it reads, a government agency reports that the mean amount of earnings for full-time workers aged 25 to 34 with a master's degree is less than $70,000. What's that? Okay. So Rebecca, what's the claim?
P, right? Or is it the
U.
U is less than 10.
Okay. Is that HA or HL? And what's your HL?
U is greater than or equal to 70,000.
Good. Thank you. TJ, what tail test do we have?
Left.
Left. So we're going to shade this in and say reject H0. And we're going to say this is failed to reject H0. We need a cutoff value. We need a TC. We know that our level of significance is 0.05. Let's pull out your sample information. We know we did a sample of 15 workers that had a sample mean of 66,231 and a sample standard deviation, this is where we knew we had to take a T, of $5,945. And we want to know, is there enough information to support the claim? Now the claim has the word support, that is our HA. So, Aaron, how'd you get your TC, your cutoff value? Inverse T. Okay. No, why did you divide by 2? Okay, so what'd you get? 1.761. Okay. Or you can go to table 5, or you can do inverse T. Okay. Now, just for the heck of it, someone do the inverse Z for me, the inverse norm. Do the Z at level 0.05. What would it be? 1.645 or 1.96? 1.645? So look where we would be. 1.64. You sure it's not 1.96? 1.645. So it's a little bit over more to over here. You get a little bit less room that way. So make sure you're in the right one. This right here is have I know. Plus, I only gave you a t-score and a proportion on your test. So it kind of should work out. Okay, whether you use your formula or not, or your calculator, just show me some work. Give me your calculator step, show me your formula step, I'll give you the formula, you give me some work. If I don't get work, or your work doesn't match, you don't get credit. Okay, so what's my T? My test statistic. What's my T?
2.4.
Negative 2 point. Everybody got that? Anybody not get that? Okay. If you don't, make sure you use your fraction bar. Your fraction bar is alpha y equals. Then you don't need to worry about any parentheses. Otherwise, you have to have parentheses here. So we come here, and it falls. Here's my decision. Reject H0. This is the decision. If you did a p-val test, look, well, you can't look this up. You have to put this in your calculator because it doesn't come out on your table. And test against your level significance of 0.05. Your interpretation is follow this one. If I reject this one, that means there's enough evidence to support my claim that the mean, whatever we're doing, the mean salary earnings is less than 70,000.
Sorry.
Make sure you write it out. Okay.